All right, these problems are factoring also, but they're not factoring quadratics. And how I know that is a quadratic equation will have terms, they'll have three terms. So these two problems, the first one doesn't have three terms. The second one does have three terms. However, there's more to the quadratic. The first term will be squared, and the second will be a non-squared x, and the third will be a term without an x. So for example, it looks like this. First term is squared, second term just has the letter x, third term no x. None of these follow the formula. This has a 3s, a number, and then a 6t, so that's not even close. And this does have a square in the front, and it has a second term with an x, but it has no third term. So we can't use the procedure for factoring, which is when you factor something like this. Okay, so if you were to factor this out, it would look x plus 2, x plus 2. Okay, so these are different, and these are the ones we worked with actually in Unit 2, where we just factored out by doing the reverse distributive property, basically. So how we do that then, we look in each term for what can be divided as a common factor. So the common factor and the greatest common factor in this case is 7x, because both terms can be divided by 7 and both terms can be divided by x. So we'll take that term that's divided and put that on the outside, and then what this reduces to goes on the inside. So 7 over 7 is 1. X squared over x is x times x over x, because x squared is x times x. So it's a simple thing of x over x reduces, so it's just x. So then you have x, this term 7x squared now reduces to x. And we're dividing by positive and a negative there, so we keep the negative, and that's a minus 3, because 7 into 21 is 3. X over x just cancels to 1, so x minus 3. So it's 7x times x minus 3. And if you were to do the distributive property, you would get back this term, which is 7x squared. 7 times negative 3 is minus 21. Then the x comes along, and you would get this back. So that's how you could do a quick check. But this is our answer here. Okay, so on this one, you're doing the same thing. You're looking for the greatest common factor that can be divided by each of these terms. Well, I can see that a 3 can be divided by 3 and 9 and 6. So 3 is a greatest common factor at least. There's a t here, but there's not a t here, and there's not a t here, so that won't work. There's an s here, but there's no s here or here, so that doesn't work. We can only divide out a 3. So we take the 3, the first term, 3 divided by 3 is 1, so then we have just an s left over. 3 divided by positive 9 is positive 3. And it's hard to tell if that's an s or a 5. And then 3 divided by 6 is 2, but it's both positive, so it's plus 2, and the t just stays there, nothing happened to it. So that would be our answer there. And once again, you can factor it all back to double check if you got your answer. So 3s, plus 3 times 3 is 9, plus 3 times 2 is 6t. So it does come back really nicely. All right.